2.2 and 2.3. So tonight is Thursday, September 30th, and we are going to complete 2.2 and 2.3. On Tuesday, we completed 2.1, and we learned all about simple and compound interest and how simple interest is like a linear equation and compound interest is like an exponential growth. And so tonight we're going to do some graphing, and the graphing goes fairly quickly. And then in the morning class, we were able to get through half of 2.3. Also letting everyone know that just to do your best getting that project done, as well as the unit review, even if it's the end of this weekend, it's not the end of the world, but I need to make sure that you're working on it. So let me know if you're having a hard time getting it in. Maybe send me some progress update. That would be great. Also, because I need to get you moving on chapter 2. The unit 2 project is out and available on JetNet, and I posted the folder with the information on the project under this coming October 5th date if you want to look for it. All the directions are there. I made a little video for it. It's much easier to follow than unit 1, so that'll be a nice refreshing thing. And then it's not due until the end of October. So you've got pretty much the whole month of October to work on that. Your hubby was there, Darla, but he just turned around. Okay, so he's so cute. So let's look at that's
my neighbor's dog.
Huh?
I said I'm sorry for my neighbor's dog.
Oh, that's all right. My neighbor's dog was in the video last week or on Tuesday. So we are going to look at the quote here for the beginning of 2.2 says, before you believe you can and you're halfway there. And that is true. Kind of like setting a plan for how you want to get things done is half of the battle, right? And getting started, thinking about things and having belief in yourself. So we're going to start right down here at the bottom of page 139. And I'm going to first talk about time series graphs. So time series data is data that's based on time. A lot of times it's years, it might be minutes or hours, but a lot of the graphing stuff that we're going to do is going to be based on years. And then this data here is years from 1993 to 2018, it says, and it's the annual unemployment rate in the US. So in 1993, it was 6.9. And then in 2018, it ended at 3.9. And then they're asking you some questions here on page 140, and then a graph of that same data, and then a question on 2. So I'll let you ladies look at those 2, and then we'll kind of exchange thoughts here in a moment. You want to share what you ladies have for 1 and 2? I can get some feedback too.
Oh, for one, I said over the course of 26-year period, the unemployment rate has been decreasing. I couldn't really tell how it was decreasing because it decreased by different numbers, I should say, but I knew it was decreasing. It's obvious.
You could tell it was decreasing in parts of the years.
Yeah.
Mhm. And that was number 1.
Yes, I was still working on 2.
Okay, yep, go ahead, take your time. Shall we share what we saw for number 2? So everybody
Well,
see,
you can see the ups and downs better with the graph,
yeah, I
and you
agree.
can see the spacing,
Mhm.
and it was pretty steady at the beginning. Even though it was going down, it was still pretty steady. And then it going up and it's not as steady, and then coming back down a little bit steady, and then it's way off the rockers.
Mhm.
And then even now it's not very steady. You have a better understanding of where the lines are because of the dots.
Yeah, I agree. I agree. Can you guys also might see my paper, or what are you looking at?
I can.
Okay, because for some reason, sometimes it goes away. Like it says I'm sharing, but I don't know I can't tell what I'm sharing.
Oh, it's sharing. I see it.
Yeah.
Okay, so let's go ahead and turn to page 141. We're going to talk about something called the rectangular coordinate system today. And it's a way for us to organize a graph so that we all know how to read it the same. So on this graph right here in the purple, it says based on figures from January to October 2019, the average unemployment rate for that year was expected to be about 3.7%. So they're showing you how they found it on the graph. I'm just gonna new share it just so I can see it again what I'm showing. Wow.
I see your hand over it.
Do you have the Elmo with you? Like the overhead switch thing?
Do I have what?
Elmo.
The Elmo? Is that what you're using?
I have a dot camera. Is it called an Elmo?
It's
Yeah.
essentially the thing. Yeah, some of them are called different things.
Oh, yeah, this is a green one. It's a dot camera. It's really nice to have. Okay, so we can see that we could write that as, let's say, 2019, comma 3.7%. So how we write them in the parentheses tells us how we're going to find them. So this is usually X, and this is always, it's always X on the left and always Y on the right. And I'm going to show you just, I'm going to draw like a graph down here so you can see how it's usually set up. So our X is our left and right movement. And so I kind of just do an arrow left. So I know that's my left and right movement. And then my Y is always my up and down movement. Kind of like north, south, east, west.
Mhm.
Except for it's east, west, north, south. So we would go over to the right to find 2019, and then we're going to go up to where it says 3.7%. So that's where they found this dot here on the graph.
It's so hard to write.
Mhm. So I'm going to actually finish drawing on this. If we flip the page, they have a graph for us, and we can kind of point out some things right here on the graph. So like I mentioned, when we write X, comma, Y, this is called a coordinate because X and Y coordinate together, kind of like if you coordinate your outfit, right? How your clothes go together. This is how X and Y go together. And like I said, the left and right is always our X. They label it right here. And then our Y is labeled here. And these lines are called our axes. So the X axis, so an individual is an axis, and two of them together is called an axis. Oh, just a minute, we've got somebody here. Yay. And then the x-axis is very much looks like a number line because it works like that. So this middle part where they intersect, that's called our origin. So it's like our starting spot. So if you were to give somebody, hi Shelby, if you were to give somebody directions around,
Hi.
how are you?
Good. Sorry I'm late. It's been
No.
a crazy week.
That's okay, we're glad to have you. We're on page 142 and it's lesson 2.2.
Okay.
So the origin is like our starting spot. So if you were going to give somebody directions to your house, you would have to know where they're starting from, right? So if we have the origin, then we're all starting from the same spot in the graph. And the origin always has the coordinate 0, 0. I'm not sure how familiar you all are with graphing, but I wanted to give this information out. And then this is our y-axis up here. Now, everything to the right of this 0, 0, x is positive, like a number line, and everything to the left is negative. And then the y-axis is is similar. Everything to the top is positive, and everything to the bottom is negative. Okay. So number 3 says, what are the coordinates of the origin in the rectangular coordinate system? Well, I already gave you that. That's 0, 0. And this is the magic lesson check number today. So you've already got your 2.2 lesson check. You can go and enter that today. And then number 4 says, look carefully at the numbers on each axis. What distance does each box on the grid represent along the x-axis? And what about the y? So we're trying to
2.
figure out the x-axis and the y-axis. What does each box represent?
2 by 2.
Are they all 2?
I think X is 1.
So the x, it only goes out to 5. So I agree with Shelby there. I think those go by 1. So 1, 2, 3, 4, 5. So the x's are going to go by 1s. But Darla, I do agree with you. You saw that 10 there, and you probably noticed that. So I think that y's go by 2, 4, 6, 8, 10. So they go by 2s. But that's
always
no.
or just sometimes.
What, hon?
Is it always going to
Nope.
by two?
Nope. So that's where it's important for them to have scaling. So we're going to see some bad graphs here in just a
Very
minute, so
cupped.
you'll know what I'm talking about. But a good graph always has scaling, so you can figure out how to read it.
Thank you.
Good question. Good question. Sorry. Yeah. So let's look at number 5. Number 5 is challenging you to plot these points. So there's 4 points. Label them A, B, C, and D on your graph. I'll give you a minute to do that, and then I'll put them up and see what we agree on.
I hope it doesn't make a line, is it?
I didn't hear you, hon.
I said it's not supposed to make a line.
Nope, it's not supposed to make a line. It's supposed to get you to practice in all 4 what we call quadrants.
Okay.
Mhm. So let me explain more what the quad means. So quad is a prefix for 4. And so you can see that our graph is broken into 4 areas, and we call this quadrant 1. And I'll spell out quadrant, Quadrant. And then it actually goes counterclockwise. So this is 1, this one to the left is 2, this one is 3, and this one is 4. And in quadrant 1, this is mainly where we're going to be this semester, because we're not really focusing on just algebra in general, but most of the data that we use is going to be in quadrant 1. But in quadrant 1, I'm going to draw a coordinate instead of putting numbers there. In quadrant 1, we can see that X, if we go to the right, X is always positive up here, and Y is always positive up here. So they're both positive. And then to the left, in this second quadrant, you can see that X is negative, but Y is still positive. Right? So if we were to look at A says 4, 0. I'm going to go on my x-axis 4, 1, 2, 3, 4. My thing went 4, and then I'm not going up or down. So A is right here on the x-axis at 4, 0. Everybody's good with that? Darla gave me a thumbs up. And then I'm going to go here in the, and then the next one is at 0, -8. So that means X is at 0. I'm not moving left and right at all, and I'm going down 8. And we have to remember that they count by 2s. So 2, 4, 6, 8. So B is going to be right here. Awesome. And this third quadrant, I'm going to show you the parentheses. This third quadrant, X is negative and Y is negative. So in quadrant 1, they're the same. In quadrant 3, they're the same. In quadrant 2, they're opposite. So let's look at 4. So in quadrant 4, X is positive again, but Y is negative. So if we look for letter C had coordinates -3, -4. So we're going to go to the left 3, 1, 2, 3, and down 2, 4. So C is about right here. And then D, excuse me, is 2, 7. So we're going to go to the right 2 and up 7. And 2 and then 7, we have to remember that going up is by 2. So we have to go between 6 and 8. So 2, 4, 6, and 8. So 7 is going to be in the middle between that 6 and the 8. So right there is letter D. Everybody's good with those? Fabulous. I'm gonna let you all check out page 143 and share your answers, and I'll be perfect to give some tidbits.
Okay, do what now? What temperature is displaying? Okay. 30. So 32 Celsius is. So Fahrenheit. These lines are too little.
I don't think you can technically know because it's not labeled. Unless you happen to have a thermometer memorized, which I don't.
Goes along with number 2. Why is it useless?
Mm-hmm.
Oh, and why is the graph useless? There's no numbers.
Mm-hmm. No labeled scale.
I'm confused. I think maybe you guys said this was when I walked away. But the 15 is only on the Fahrenheit side. We use that for both sides? Or just the one?
The
You guys are
thermometer
so-
doesn't have numbers, so you
You guys
can't
are so-
tell what
Right,
temperature it is.
exactly. So there's no scale. It's a big question mark, right?
Okay.
Do you
I'm
guys think I left you to a
overthinking.
puzzle?
Yeah, I was overthinking it. You heard me. You heard me ask about the
Hi,
15.
Teresa.
Hey, Teresa.
Hi,
Oh, too funny.
sorry, something came up unexpectedly after I got out of work. I'm just now logging on,
Oh,
so.
that's all right. We're just doing graphing, so I don't know how familiar you are with graphing, but so that's where we're at. And we're just looking at 2 bed graphs. This is a thermometer and it said, what is the display saying, what temperature, but we can't tell. It's right there. We know it's warm because it's in the red, but that's all we know. No scale. What
Well,
about this
what-
point right here?
Number
Trying to
3.
see what page you're on. Oh,
Page
okay,
143.
143. Okay,
Yeah.
got it. Okay. I'm
Well,
caught
I
up.
mean, if we use the same numbers as the other graph, it would be, I would think, -2 up 8.
But we don't know though, right? Because there's no
Right.
scale. So
There is no
exactly.
scale.
So this is another one of these. Because there's. no
That's if we
scale.
were using the same numbers as the
Right.
other scale.
Yep,
Did I have it right?
yep, you did. If we use the others, you were totally
Okay.
right on. So down at the bottom, just some good notes for what a good graph would contain, making sure that you've labeled your axes. The graph has a title. And you've got scaling. So all the things that were on the first graph shows what a good graph would look like.
Okay.
So the next graph, we're going to kind of do in some Desmos because there's benefits. So I'm going to kind of walk you through it just so we can get part of 2-3 done today. It says almost everyone is interested in gas prices. They have a very real effect on a household budget. The data in the following table show the average price of a gallon of regular unleaded gas in the US in January of each year. So this is January. It's not really showing the rest of the year, but it's January. So consistently every year from 2006 to 2016. So if we were to graph this using a coordinate pair, notice this would be the coordinate point. Years after 2006 in price per gallon, price per gallon. The reason we have to use years after 2006 is because if we were to actually try to graph on a scale the year 2006, the scaling would be so large, it would be hard to see on the graph. And so we use a base year. I'll always give you a base year, or if you're doing your own, you'll let me know what is your base year. So because 2006 is my base year, I'm starting with 0. And then 2007 minus 2006 is 1 year after 2006. So does everybody see where this is going? 0 through 10. Then they listed the prices for gas in those years. So I'm going to show you what a couple of the coordinate points would look like. We don't need to write them all out. You just need to know how to do it. So it's your X, comma, your Y value. So for instance, 2011 would be 5, 3.09. 9, 2.11. If you have decimals pulled up, or if you want to get it pulled up, that would be great, because I'm gonna show this in there.
The graphing calculator or just the regular calculator?
Oh, turn it. Desmos. Their graphing calculator, yep. I exited out of the wrong thing. Okay, so everybody has some of that done. And then, of course, we could go ahead and graph these. Oh. What did I do? Uh-oh. I'm curious with myself. I lost my paper.
I graphed it on this one.
No. I was going to show you. Okay, shoot. I don't know what I did with my paper. bound. Gee. Okay, here it is. So this is what it would look like if you made your own graph. Can everybody see that? So you could plot them accordingly, like I have here. Making sure that you've got your years since 2006 at the bottom of your graph and your gas in dollars. They already gave us a nice label at the top and they already had scaling on there. But I'd like us to move to Desmos to put these in so that.
Your mom's gonna be on her way in just a minute, okay?
Yeah. So I'm going to go ahead and enter so that we can see the big picture. It's kind of nice to enter it right in here. So we're going to enter year 0, 1, 2, and Desmos learns the patterns. You can go all the way down to 10. And then I think I lost one. Okay. So does everybody have see mine or have theirs in?
Mhm.
And so it will do scaling for you. You can grab it and move this graph all around, all that you want. But over on the left, you see where my mouse is? If I hover over this magnifying glass, it'll say zoom fit, and I'm gonna click on that. And sometimes you have to click on it a couple times to get it to zoom so it will look clear. But does everybody see my gas prices? It looks pretty good, like what I had in my graph by hand, but obviously this is much more accurate. Any questions so far? So that's with our graph in. So go ahead and use either your hand graph or the data or my graph to answer question 7 through 13. By all means, share with each other. And then I want to make sure that we do 14 and 15 together. By all means, share your answers if you want. Anybody ready to share 7, 8, or 9?
I'm sorry, what number did you say?
7, 8, or 9?
Ooh, what was the highest price of January gas between 2006 and 2016? The answer based on the graph for why? I would say the highest price in January was year 6, which was 2012. And $3.40.
So what did everybody else say?
And
I
it looks
agree.
like on the graph, it was the same thing.
Okay. Yeah, and it's quirky. 7 and 8 are quirky because it feels like it's the same question. But 7 says, what was the highest gas price? And you said it was the 340.
Yeah, in 2012,
Yep.
highest gas price. It was looking at this, I mean, yeah, 340 is the highest.
Yep. So it said, what was the highest gas price? And then question 8 says, when was gas the most expensive? So it says, again, you may have 2 slightly different answers, but it's still $3.40. It's just now they're asking when, which we all agreed it was 2012.
Oh, okay.
I know, it feels like it's asking the same question, and
What?
it wasn't
and
until
when?
this
Okay.
morning. I'd already done it yesterday, and then this morning I was like, oh, now I get, they're asking what
What?
and when.
And see, on my answer, I put year 6, 2012 and $3. I put all 3 of them on there just to make sure I had it right.
Yeah, no, that all is correct.
Okay.
So what about 9? Did anybody get that one yet? When did gas prices stay relatively level from one year to the next?
I said 2012 to 2014.
Yeah, there was about 2 or 3 years there, right, where they were about level. So 2012 to 2014 or so, yeah.
Now, is there any, from one year to the next, does that mean just 2, or does that just mean like in a range?
You could have said just one switch so that it'd be 2013 to 2014 only had a 3-cent change, but really it's
Right.
about 3 years in a row that looked plain. So
Okay.
it's on these ones in the workbook, some of these, it's kind of just your flexibility of reading the graph. Like, what are you taking away
Okay.
from the graph?
Okay.
10, we already did the, just so you know, Teresa, on the lesson check, because you just missed that. It was actually on page, I don't want you to miss out on that. Could somebody help me out? What page was that? 142?
142, question 3.
It's 142, question 3, and it was the origin, which is this coordinate right here.
Okay. Got it.
So I just don't want you to miss out on that.
Thank you.
Okay. Okay. So here we are. So what about number 10? Over what time spans were gas prices rising? I found a few, so you might as well.
Well, 2008 it rose.
I was gonna say it's a few gaps when it went up and then it went back down.
So 2008, yep, I had a couple, 2000,
Seven.
2007 to 2008, right? In between there, it jumped
Yeah.
up. And then it jumped again. I had 2009 to 2010.
Mhm.
Mhm.
Went up and down.
Okay. And then it says, over what time spans was gas prices
9.
cheaper?
2015 to 2016 it went up, or no, it went down, sorry.
2015 to 16, it did go down, yep.
From 2008, 2009, it dropped down a lot.
It did, didn't it?
Yeah.
2000, what was that? 2008 to
8 and
2009.
2009.
Mhm. Number 12 says, what was the largest single price change in 1 year?
I think it was $1.26 between 2008 and 2009.
Yeah, because it doesn't say up or down, it said price change, so.
Yeah, so you said,
2008
Yeah,
to
Shelby
2009.
hasn't, Shelby knows about gas prices.
yep.
I'm very familiar.
Right, this is right up
It
her
was.
alley here.
If we take the 2009 and subtract the 2008, right? We get that it dropped because it's a negative $1.26.
Correct.
Mhm.
And we had a huge one actually over 2020, but it was already kind of low at $1.97. But down in 2020, 2020, I think it was over COVID, it was like down to like $1.40 something maybe. Does that sound right, Shelby, over your way?
I think we went down to $1.20 something at one point.
Wow,
My profit margins were terrible.
I can imagine. I wasn't driving at all, so I don't remember that. And then 13 says, explain why we didn't bother to include negative values along either axis when drawing the rectangular coordinate system for the gas price graph. So why didn't we draw over here and why didn't we go down here?
Because we never had negative prices or negative years.
Okay, so time, there's two things. So time cannot be negative. And gas price cannot be negative.
That's true.
There you go. Everybody good with those? Give me a thumbs up. Anybody have any questions so far on those? So are we okay to move on to 14 and 15?
Yes.
Yeah.
So 14, if I offered you one of the two accounts detailed below, which would you choose and why? So what's your initial choice and why?
Well, if you look at year 4, account 1's going to give you more money.
Okay. So your initial is account 1. Anybody else have a thought?
Just looks like the account 2 gained more money in the 4 years than account 1.
Yeah.
I mean,
Yeah,
if
I
you
think
work
if
it
we're doing
out like you're
interest,
supposed to,
it's
yeah,
actually gonna make more.
eventually it will.
Eventually what will?
2, I would think.
Okay.
Even though it doesn't look right because it's consistent and account 1 because it's linear,
Mhm.
I think as the time goes on, account two will eventually go ahead of it and have more interest.
Okay. I, I I like the discussion. So let's just look down. It's the same data in 15. It says when we plot points on coordinate system that correspond to pairs of data, we call the result a scattergram or scatter plot. And that's what I'm showing you on StatCrunch. So this is just all the same data. So it says after writing ordered pairs, which you don't need to write for me as long as you understand how to graph them. For the bank accounts in the two tables below, create a scattergram for each. First, you'll need to complete the table using skills we practiced earlier in the course. So what did we learn in unit 2.1, lesson 2.1? What did we learn about?
One was a simple and one was a compound.
Okay, so we learned about simple interest and compound interest. Does anybody remember, what were the unique things that identified the two of them? What were we looking for at the end of Monday or Tuesday night?
One is addition and one is repeat addition, and one's repeat multiplication.
Yep. Okay, good job. So simple is the repeat addition. And compound, this does not replace the videos from Monday, Tuesday, right? Because that was a whole thing with us ladies, but this is just a recap just to help us keep moving on this. And then compound is the repeat multiplication. Okay, so does it look like we can identify either of these as one of those?
Simples
I
on
would say that,
account one.
You count one?
yes.
Okay, and how do we know with that, Darla?
60,
Okay,
add 60, add 60, add 60.
okay, so these are all adding 60. Okay, so if we go back to our format that we learned in lesson 2.1, the amount, right, for any given year was the original amount, which is 1,000, plus the repeated amount, which is 60, times the years or the time, right? So I'm going to put T for time. So that's what our expression would look like. So it looks like we're just adding 60. So after 5 years, how much do you think we should have in the account then if we went from 1240 in 4 years?
1,300.
1,300. Okay. I would agree. I would agree. And then the other account too, what does that look like as a pattern, if any? Let's use our strategy that we used.
Divide.
It was what?
You divide like 4 years into 3 years and then get the difference, and then 3 years into 2 years and get the difference, right?
Okay. Did you divide
Just
those?
to check. Or am I thinking the wrong way?
I hear you, but you're kind of fading out a little bit. Did you divide those, Teresa?
That's what I'm saying. Divide 121551 into 115763 and see what your answer is, and then do the same from the number 3 years to the number 2 years. And if it's, yeah,
Mhm.
that's how you get your compound, correct?
That's how we would see what the multiplier is. Yeah.
Right, right.
Does anybody see if there's a multiplier? Because we found out on Tuesday, we said, well, if it was adding the same amount, this was adding 50, but the next one's not adding 50. So we know it's not the same addition. And so who was on? Oh, Sandy was on with us on Tuesday, right? And she said, well, if she took 1,050 and divided 1,000, she got a multiplier of 1.05. And then she took 1,050 and multiplied by 1.05 to see if she got the 110250. And then she did the next one. So everybody should be trying to practice some strategy to find out what it is. There's a couple of different ones that we could do.
No, we have our answers. Do you,
Sure, if anybody wants to share.
no, I mean, when we do them, do we round?
Oh. If it's
Or
not
we
quite,
projected if, like for number 5, I could round it up. Change for, if I did number 5 from number 4,
mhm.
be 285, so jumped it up to 29 for the change.
So what did you get for your multiplier? Oh,
For year 5, $1,276.29.
oh, if you were gonna use the same multiplier?
Yeah, 1.05, correct.
I didn't hear anybody say the 1.05. That's
Oh,
okay.
I'm sorry.
No, that's all right. I just,
And my speaker up here.
my computer is kind of hesitating. So you came up with 1,276 and I did 0.29.
Yep, so did I. Okay.
Okay, perfect. Sorry about that. So back to the fact that we see that there's a multiplier of 1.05, we're going to write out our pattern like we did for the linear over here. So the amount A for a compound interest is your starting value 1,000, right? And you're going to multiply that by your growth factor, which is the 1.05, and then you're going to have an exponent of your time. So we see that? So I'm going to go ahead and share my Desmo screen again. And I'm going to go down here where it says Y4. So don't look at my table that I made up of Y4. We're going to go back to that in a minute. But the Y4, I'm going to delete that. And I'm going to type in the, I'm going to type in my 0, 1, 2, all the way to 5. And then it was 10, 15, 20, and 25. Okay, so up where my Y would be, I'm going to type my expression that we had for the linear. So 1,000 plus 60, and my first column is X4, so I have to tell it to use X4. I want it to use that column, and it's going to multiply by 60 and add 1,000. And did it give us all the numbers that we had?
Yeah.
It sure did. So year 10 would be 1,600, we can fill in. Year 15 would be 1,900. Year 20 would be 2,200, and then 2,500. So be with me on that one. Then I'm going to go over to the column. I'm going to bump into the column next to it. I'm going to say I'm going to do something over here. So in this one, I'm going to put in the expression that we just said. So 1,000 parenthesis 1.05 parenthesis. And then to do the exponent, remember it's shift in the 6 key And then I'm gonna put X4 because I wanted to use the X values just like we did the years. And then it did give us the same that we had, right? So 1,000, 1,050, 110250, 1157. The decimals are up just a hair because of rounding. 1215, 1276, 1628, 80 is the 89 cents. 2078 and 93 and so on. So what I'd like to show is that will graph for us if we want. So I'm going to go over to my magnifying glass and click on it. And then it did plot those. I must have done, oh, my other one up here is not. I'm going to turn these off for a minute. Okay. So it looks like my compound at about year 8 or 9 in here, it does start to outweigh the linear, and you can see the compound does grow quicker. So we see that.
Mhm.
That's so you don't need to answer questions 16, 17, 18. We just want to see that we're verifying that we understand the graphing of what we did on lesson 2.1. Now we're putting it into graphing, and we can start to see visually the difference between exponential and linear, simple and compound interest. So why don't we take like a 5-minute break or so, and when we come back, we're going to start on 2-3 on page 157.